Welcome back, and let's get started with Python Lambda Expressions, which are also known as anonymous functions in Python. And before I get started, I wish you a happy Ramadan. I hope you're doing well, right? And it's going to be a real fun. Lambda expression is something that I love in Python, right? Anonymous, a function without giving it a name. So let me elaborate it a bit, and let's start with the basics to the intermediate and the advanced level. So we'll see while we go through the program what Lambda expressions are, and for that we know that we use Anaconda. Those who have not downloaded, so there are people who requested me to remake this video, so you can easily see those who have not downloaded Anaconda can download this from anaconda.com, right? So they can go and your data sciences toolkit, and you can find it here. The download is here. I can keep the download link available down in the description section. You can go directly to the description and start downloading it, right? So now you can download it. Once it's downloaded, you install it. Once you're done with installation, right, so we are going to deal with this spider right here. I don't know, it's hidden somewhere today. Right, and so we are going to start with spider, so I'll say launch. Right, after clicking the launch button, so now you can see spider is going to be launched, right? So now this is spider, right, and this is how we can work with the spider, right? A spider will only work or we can only use spider for object-oriented programming, till object-oriented programming. And before we move to data sciences and ML, so we are going to completely upgrade our system, right? We are then going to use this Jupyter notebook. Spider is here. We already used spider, right? And then we are going to use Jupyter notebook. All those who have not downloaded Anaconda are hereby advised to download Anaconda and then install. You can see that I'm getting launch. So once you download it for the first time, you will not get launch, you'll get install, right? So now, once we are done with installation, then you can say launch. Now I need Jupyter Notebook, I need this console here, I need Spider to be installed, and the last thing, which is this VS Code to be installed. After their installation is done, now you can start with this spider right here. To start with spider, right, I have many files opened right here, right? So now in order to get started with spider, let me say close all. So let me go and create a new file, right? So this is my new file, and I'm going to save this file as class 20 or class 10, whatever you may call it, and let me just zoom in so that you are able to see. Now we'll get started with Lambda expressions. Now Lambda expressions are Lambda functions, right? You can call Lambda expression Lambda function, right? And you can call them expressions and functions both. And now if you call them functions, they are functions without names, means they are anonymous functions. Now there are two different things that you might learn while learning Lambda expressions, right? It's not only Lambda expressions. I may have to teach you another thing which I was not sure that I'll teach you. Right, so that is arguments, which are args and KW args. What are KW args and args in Python? So that's also advanced Python. So let's start with Lambda expressions. Now I'll give definition to each and every one of it. So now this x, right, you can see it is just a variable which is going to get assigned something, right? So I'll say is equal to lambda, and this a, right, is basically bound variable, you can say that, right? And we can say plus a plus 10. Now you can see if I say print x, right, now what do I get? I do not get anything at all right here now, because we'll have to supply anything to a. Now you're saying a 10. Now this is called also, I call this as a such that a plus 10. So now what is a lambda? Lambda is a keyword. I repeat here. So here lambda is a keyword, right? So is that done? Lambda is a keyword, right? And bound variable, right? So a, or we can say a here, this a is a bound variable, right? So bound variable with lambda, right? So it is, right, a, right? So a is, or we can say a is a bound variable, or you can say it's a range variable with a lambda, right? And another a is body variable, right? This is the body variable, this is the bound variable, and this is keyword. Lambda is a keyword. Now what happens, right? So you're calling x, so now you're not going to get anything because unless you supply anything, right? So once you call this x, now once you call this x, it's a result of this lambda expression which takes one parameter, which is this bound variable. So unless you supply something to this bound variable, nothing is going to happen. Now I supplied 5, now you can see I'm getting 15 right here. So using spider, you'll be able to just make it little. Okay, now this is your console right here, so you will be able to see, you can expand, right? You will be able to see all the results here. Now you can see I'm getting 15, so 5 plus 10 is equal to 15. I repeat, this 5 is applied to the bound variable and the body does the job. So now body does this a, takes this a, right, and adds it. It's as simple as anything. Now you can see with named functions, how do we do with named functions? I'll say define, right? For example, I define sum and it takes one parameter a, and now I can say return a plus 10. So I can do this. This is same what's happening right here, right? So you are supplying one argument here, a, whenever you call this function. So for example, I have to call the function. I will say sum and I need to apply one argument, which is going to be, for example, 5. And that argument is used here, that is the parameter which is going to use here, and you are returning the same back to the function. So that's what's happening in the lambda function, or that's the same which is happening in lambda expression, right? X is here, then you supply 5, this 5 goes to the lambda bound variable, and the rest is done with the body and return back to this s. That's why we get 15. So that is one example of lambda expression. So let me comment this out. Alright, you also take note while learning, right? So you can apply the function above to an argument by surrounding the function and its argument with parentheses. Yes, we can do that. For example, if I want to run it on command level, for example, if I go to IDLE, right? So let me go to IDLE. For example, I want to run it on shell at command level immediately. So I can say LAMBDA lambda x, which is the variable, bound variable, I have to supply it, x plus 1. Alright, now you are going to execute it. Now what do you supply? I will say I supply 2. Now what is going to happen here? This 2 is going to go to this x plus 1 is 2 plus 1, 3 is going to be the result right here. Now you can see 3 is the result. So you can do the same right here, right, and you can get the result, but yeah, you'll not get it here unless you print it out. For example, I'll say x is equivalent to, then I say print x. So that is what is going to happen. You're going to get 3 right here. So right, what is happening here? You can apply, I said earlier, you can apply the function above to an argument, right? So you're applying this function above to an argument by surrounding the function and its argument with parentheses. Now if you want to run it directly, you don't want to assign it to a variable or anything like that, I want to run it directly. Now you can run it directly, you can see. Now why do we use it? You just have to learn the syntax of how we are using it. You will, once you move to more advanced and more data science features, you'll only come to know that how important are these lambda functions or lambda expressions, right? Or what I can do, what is happening here. So let me show you what is happening here. Alright, so what is happening here is LAMBDA lambda, this 2 goes to this x, so this 2 goes to this x, and you take this x which is here. That means when you are supplying 2, this goes to this x. You're taking the same x which has 2 plus 1, you're taking that value, right, and it is going to be the value which is 2 plus 1 is equal to 3. So this is how it works. Alright, this is what is happening here. Supply 2 goes here, you take 2 and add 1 and return back to the function, which is 2 plus 1 is equal to 3, right? So this is how we can work with lambda expressions, right? So we can surround we can surround the function, right, and its arguments, right, with parentheses, right? Yeah, we can do that. We can surround the function and its argument with parentheses, just like we're doing here. Is that understood now? Right, so I'll just keep this also commented, right, and I'll share this file down in the description section. You can download it from the description. Alright, so now let me have few more things, right? For example, I just shown you yesterday, but I'll show you again. For example, we have full name. I'll say full name is equal to, now I'm assigning something to full name, which is going to be my lambda expression, right, and it is going to take 2 parameters, which is f name and l name, right? And now I am returning back a formatted string, which is full name, right, and that full name is going to be, right, and that is going to be the expressions you are accepting, f name and l name, right? So let me just, okay, so now what you are doing, you call this lambda expression, right, you call full name. Now you have to expect, now if I call full name, now because it's an inline function, anonymous function, you have to pass arguments. Now you're calling it, absolutely, there's no error, but yeah, you have to pass 2 arguments, which is going to be the first name and also the last name, right? You can even say like this, right? You can say lambda is going to return me the full name, and it's also returning the formatted string, right? And this is much faster than named functions, right? I can say input, hey brother, I need you to give me an input, all right? I will say enter your first name, right, and let me document it. So I'll say input second value, enter your last name. Is that clear? Right, so enter your first name, enter your last name. What is FIRS? And this will go into f name, and this goes to l name, right? Alright, so now if I call full name, so I can say I want to print this argument right here, which is the full name argument. So I can call this full name argument, and I can pass 2 things, which is f name and l name. So let me run this program and see what I get. Yeah, enter your first name. You can see here I'm getting enter your first name. So let me do this using, okay, I'm getting here enter your first name. I'll just take it here. Now can you see this? Enter your first name. I will enter Fahim. Enter your last name. I will enter Khan. So now full name Fahim Khan. So if you want to give a bit of space, you can give. So let me run it again with a bit of space. So I'll say FAHIM KHAN. So I get Fahim Khan, right? So this is how it works. Either if you want this input, you can directly save variable spaces. You'll go to print directly, right? You can see input and input. At the place we used to supply 2 variables, now what I do, I directly take input. Now you can see after comma, I'll say, hey, full name takes 2 parameters. Now call full name, it's a function, and print the result of it and pass 2 parameters both from input. Now you're saving memory here. You're not initializing two variables here. I can say enter first name, that is Fahim, whatever, and Khan. So now I get the full name right here. So this is what we can also achieve by using lambda expressions, right? Single line. So we are reducing. Now that is the fun of using any bigger framework or any bigger programming language or any high level programming and scripting language, that it reduces the amount of code that we minimal or that we usually write. Usually if we write 20 lines of code, tomorrow we may get a framework where we have to write only one instead of those 20 lines. That is the magic of frameworks that we are using. And here Python, it does a real magic, right? And now, we can use even command line. So this is related to exam, purely related to exam. For example, if I say lambda and I accept two parameters x and y, and then I say, now if you are supplying two parameters, I want the return value of x plus y. Now if I go ahead, now we can see the lambda is executed. Now this is also saved. Now you have to call this lambda function, but it has no name. You have not assigned it to anything. What you can do, you can use underscore. So I have already told you, remember class 3, class 4th, that whenever you want to take the output of the previous result, or you want to execute the previous result, right, and that's where we use this single underscore, and now you're calling the previous thing that has happened, which is lambda. Previous thing is lambda that has happened, and you're passing 1 plus 4. Now you'll get 5. You can clearly see that previously lambda used to happen. Now if I call again 1 plus 5 previously, so now because previous is this, previous is not this, right? So this is how what we can do. I repeat, now it is the last execution. This underscore means the last execution. Last execution is lambda. Now once I pass 10 plus 10, I should get 20, because the last execution is lambda function taking two parameters and returning the add of two parameters, sum of two parameters. But now it is not the previous. Previous becomes this. What is previous? Earlier previous was this, then we wrote this. Now previous is this. Now if I write this again, I'll get an error. Why? Because you're not calling lambda, you're calling this function which is previous to this, right? As simple as anything, so it has nothing to do, right? So let's carry on with the lambda expressions more. Okay, let me just carry on with more lambda expressions. You've seen this as well. Yeah, as I have seen, you can pass multiple parameters in square braces. You can do something LAMB. You can do something like this: lambda x and comma y, right? Two parameters I am expecting, and I am giving you back x plus y. Both the parameters that you are going to supply, I'll give you the add of two parameters, and now you can go and supply two parameters right here, and you can print this out directly, right? You can see supplying two, and now these two parameters can be input. Now see, you're doing everything in a single line. I can say input, right? I can say here enter num1, and here also in a single line enter num2. Now let me run this. I get enter num1, I'll add 10, enter num2, I'll add 10, 1 0 1 0. Why? Because we have the typecasting problem here, because we take input as string. You already know that, right? Okay, let me even verify that and do something to that as well. Right, you can do that. Yeah, why not? So I will take it at runtime again, convert it to int. At runtime again, convert the input back to int. You're already aware of this. Now you can see the single line is doing our job. How beautiful is lambda? I'll say 100, 1000 plus 1000 is 2000. Now you've successfully been able to convert. Right now, what you can see, you're not seeing that you're doing everything in a single line. You're printing, you're taking input, and you're calling lambda expression. That is why we use lambda expressions tomorrow. Why writing a huge amount of code when we can do it just like this? Right? You can see that you are doing it just like pro. Everything is happening so smooth in here, right? And this is again what you can do using lambda expressions, and there are many different things. Lambda has just started, I have not ended lambda right yet. Okay, so I've shown you that also, and we have seen the previous operation. So lambda function can be higher order function by taking a function normal or lambda as an argument, like the, I'll show you like this, what I'm going to show you. I said a lambda function can be higher order or it can be a lower. If you want your lambda function to be higher order function, right, it should take a function. So I'll tell you how. I will say high underscore order function, right, is equal to lambda, right, and it accepts one variable, bound variable here, and the body is going to be right here. Now see this, right, it is going to be func, right, of, let's say, about x plus func and x, right? Okay, now if you have that function right here, because you have to use this function, so let me have this in a different way. For example, high order function, so I will say, let me use it like this. High order function is equivalent to 2, and I will say lambda, right, and I can say lambda x such that x is going to be into x, right? So now you have to supply this here. So you're supplying, maybe it looks like you're supplying that 2 in here, right? So which is going to get that this function is not defined. Had this function being defined, so you would easily get this, right? So for example, let me not show you this, or let me not show you, I've shown you another thing yesterday. I've already shown you that yesterday, but yeah, for that I'll have to define map first. Let me skip this to the later part of this class. Today only, yes, but yeah, I don't want to get map, zip, or filter in between lambda expressions. I want to stick to lambda expressions, right? And let's say about, and at this point you may wonder what fundamentally distinguishes between a lambda function and an ordinary function from a regular function, right? A single return line, maybe under the surface, maybe you're not returning here, you're returning there, right? So now that this module here exposes to analyze Python's bytecode generated by a Python compiler. So let me see that. Let me go to idle and see the Python bytecode generated. Fine, so I will say import. It's just to check, right? It's just to check. It's not nothing. It has nothing to do with programming. So I'll say import dis. So now imported dis. It's a bytecode generator, Python bytecode generator. I will say add is equal to lambda lambda, right? And it's going to accept x and y, and such that x, let's say about, we are going to do divide, or we may do plus. Let me do plus y. Okay, so now this function is done. So can you show me this type of add? What is the type of add here? So type of add is function. It's clearly showing me function, right? So now can you show me, I've imported this to show me the distribution of bytecode here. So I'll say this dot this of add. Please show me the distribution of add. And now you can see the distribution of add is load fast, right, 0, load fast xy, binary add, and return value is this, right? So this is how the byte, or we can say the bytecode is generated by the Python compiler. So this is bytecode generated by the Python compiler. Now if you go and look for an ordinary function, right? So let us see. If I say define add, now add is, this is the distribution of bytecode for lambda expression. Add is a lambda expression here. Now here we are going to see as that of the normal function. If I say x and y, so I'll say define add, that takes 2 parameters, x and y, and I say return x plus y, right? Now we are going to return back to the function x plus y. So that is already, oh, what happened? Maybe some error. What is wrong here? Maybe we've taken it in two parts, who knows? Yeah. So define add and okay, then we're done. So now I can do the same. I will say, hey, what is the type of add here? So you can see the type of add. What? Alright, let me do this again. So I'm getting this here. Let me do this again. Import dis. Now it is done. So I'll say add. I can say type of add. I'm getting function. I'll say dis dot dis bytecode distribution of add. So I am getting this. So let me define a function now, which is going to be not add. So let me call this something else. Add, not add, but add. So it returns x plus y. Okay, so this thing is done. All right. So I will say, give me type of add. What is the type of add? So I get function. So give me distribution of add. So you will see that it's same. There's not going to be any difference in the distribution, right? So now we can say that the bytecode interpreted by Python is same for both functions. I repeat, this is an interview question, this is an exam question. The bytecode interpreted by Python is same for both functions. But you may notice that the naming is different. Yeah, naming is different. It's always going to be different. The function name is add for the function defined with def. Right here is add, whereas Python lambda function is seen as complete lambda, right? So it will be seen as lambda, right? Okay. So class function is there. Yeah, that is not a problem. For example, if I say add right here, okay, so now if I say I want to call add, now you can see add is function, but it is lambda. Now if I call this add, now it is function, it is not getting this lambda here. So this is very important. I repeat now, final time I repeat, and it's more important, you got to remember this. Right, the bytecode interpreted by the Python is same for both the functions, but you may notice that the naming is different. Why is the naming different? Right, you can see once we have printed, or we can say the function name is add for the function defined with def, whereas Python lambda function is seen as lambda. All right, you can see with def we have function as function. You can see an address of the function, but the function is also defined as lambda. Right, if it's a lambda, that means it is going to be type lambda when it's lambda, but it's not going to be type function, right, when it's only function, right? So that's very much understood, right? It's not a big logic, or it's not a hardcore logic to understand these sort of things. But yeah, unless you understand them very well, you're not going to get, right? And we are going to perform some major operations from the command line as well. For example, if I take this, let me go back here and show you this. Lambda. If I say lambda, and I can say braces, I'll use braces right here. I can say this is the variable. Now, when I call this lambda function, I have to supply this variable, all right? And I can say I want to get the numbers which are divided by 2. So I'll say x divided by 2. It's the body, right? And right, I can say odd or even. So now what this piece of code does, so just a moment, so I'm not, just close it here and supply the value input. Now I can say I'll supply the value here, input, and let me say it's going to be int. I am going to convert it to int, and I will say enter val, right? Now let me run it first. Okay, now it's executing absolutely all right. Now what is happening? The first time you enter value, there you're getting enter val, Whatever you enter, for example, if I enter 10, so that 10 will go in x. Is 10 divided by 2? If it is true, you are getting output as odd. If it is not, you are getting output as even. So let me see. And how useful lambda functions and lambda expressions are, right? So enter val 10, right? Okay, so I'm not printing anything, right? So I have to print it. I can print the whole thing. I have that tendency, but I'll say result. I'll say result is equivalent to this, right? Okay, let me take it like this. So result is equivalent to, okay, let me take it here. Result is equivalent to, and I'll say print the result result. Now see, the single line code is doing magic for us, right? And I will say enter the value. I enter 10 here. I enter 10, I get even, right? Why do I get even? Because it is going to be 0. X divided by 2. Is x divisible by 2? That means, is it true? True means 1 and false means 0 right here. So this is how we can solve these problems by lambda expressions, right? That means you are going to get and, right? If it is, you are going to get even. If it is not, you are going to get odd, right? For example, if I even say is equivalent to 0 here, so we are going to get the same thing, right? So I'll say 10, I'll get odd. Now I'm going to get the reverse thing now, right? 10 is going to be odd, right? So I'll say is not equivalent to 0, then it's going to do the same thing. Now I will get even. Now it depends on how you want to execute it. Now you're getting even. So that is doing reverse. If it is not equivalent to 0, right, then you print odd. If it is equivalent to 0, then print even. So this is how and odd. So this and is going to print when this thing returns false, and this is going to print when this thing is true. Now you can see that you're solving many things using a single line using this lambda expression, right? So there's more to come with lambda expression. Let me later to go. Sorry, I just had a great tongue twister. Tack. So I had to say, let me take a look at time. So time is good enough. So I am good enough. I'm having well enough time still. But yeah, now let me show you a few more things with lambda expressions, right? Okay, now let's continue with lambda expressions here. So let me type LAMBDA lambda, right? And single line expressions. I'm going to show you single line expressions. You can type it like this, right? And let me instead go to the IDLE Python shell, and let me say LAMBDA lambda x and y, right, and z, right, and x plus y plus z 1 2 3, right? So now I'm getting 6. 1 plus 2 plus 3, 1 plus 2 plus 3. 1 goes to x, 2 goes to y, 3 goes to z. Bound variable body does the job, returns it back. 1 2 3, 1 plus 2 plus 3, 3 4 5 6. Yeah, absolutely right. So now I have few more things, but for that, that's why I say I'm being forced. I had no intention of showing you args and kw args, but I'm being forced to show you because of this, because of the following reason. For example, if I do this lambda, right, and I say star args arguments, and then I supply, right, any argument, right? So I can now supply any argument, all right. And what do you want? I want the sum. I'm calling the sum function math.sum here, right? I want sum. Now I want to show you that you can still call sum function. Just a moment. So I can call sum 10 plus 20. Now you can see you're getting error. Why int object is not iterable? Yeah, it's not. They're not iterating. So let me basically call this here and see how it works. args, right? So this is how my lambda function is going to work. 1 2 3 4. Now see that I am getting 10 right here. Now you will say, hey sir, what have you done? right? Let me take that code also here so that I can share this with you. Now you may say, sir, what have you done? You're supplying 1, 2, 3, 4 arguments. What is happening here, right? What is this args doing, right? So now what is this? This is called as arg, and now you can use another thing which is kw args, right? So this is a new topic, right? I can supply as many parameters. You want to add 4, 5, 6, 7, 8, 9, so you can add as many as you want. You don't have to increase, right? You can see this. You don't have to increase, right? So I will say result result is equivalent to this, and I can say print. So I don't have to now, if I am supplying 9 parameters, I don't have to accept 9 parameters here, because I'm using this asterisk right here. Now the result is 45. Go, it's your homework, go and count, and you can see that's 45. Yeah, exactly 45. So that's not my job right here today. So args and kw args is the next topic. So I told you that I had no intentions of teaching you, but yeah, since you want to understand completely, and as promised, you will be learning it completely, lambda expressions and everything that follows, I may have to give you a separate class on args and kw args, right? So that is going to be tomorrow. Promised, args and kw args will be tomorrow. But yeah, as I had some calls and some messages from students that they have not understood map completely, right? So they have not, I repeat, they have not understood zip, they have not understood map completely. So now I am going to give you the rough again about zip and again about map and other things, right? And then tomorrow we are going to get going and get started with args and kw args. Now what is zip? I told you how many times that is zip, right? Alright, so zip is a built-in function. So any function which you have not defined yourself, right, has parentheses, means it's a built-in function. So I told you it, is iterates over multiple, iterables in parallel, right? Right, in parallel, meaning with zip we can act, right? We can act we can act upon 2 lists at once, right? Once. So now demo. So now here is the demo, right? I said it takes 2 iterables. Now iterables is items 1, right? I've shown you this previously. I'll show you again, those who have not understood it, right? And for example, we have this iterables, items 1. So I'm taking this as an iterable, right? Okay. So now iterable can take any iterable, like you know that iterables means list of things. It's not a single thing, it means list of different things. So that is going to be, for example, 1, 2, 3, 4, 5. And I did it last time, I'll do it today also, blue, right? And item 2 is going to be red, and then I'm going to have green, and then I'm going to have white, right? And then I am going to have yellow, or we can say yellow, whatever it is. Now this is a separate list. Now another list is going to be items 2. I'll say sky, and then I will say sunset, right? And I'll say lawn, and I will say pillow, right? What is this? YELLOW. Why do I spell it? Yellow. And what is yellow? Flower, right? So now how do you join them? So I can say, right, print, or we can say L, or we can say full items is equivalent to items 1 dot You can say, can I do this? You can say dot extend, dot insert, dot pop, dot remove, dot sort, dot add, and all the things that you can do with items 1, right? Or you can say items 2 dot append. You can say, yeah, can we append items 2 dot append items 1? That can be done also, right? Yeah, we are doing it. Now if I print full items, right? So we are not going to get the desired result here, right? If I say print full items, you will see you're not getting desired results here. You're getting none, right? So now what I want them to be joined. So I can say items 1 plus items 2. Now this can be done as well, right? And then you can see you're getting like this: blue, red, green, white, yellow, sky. I want them to come parallel. I said zip is a built-in function that iterates over multiple iterables. I want iteration. Iteration means from here to here to here to here, but I don't want to iterate alone. Hey blue, I want to take sky with you and I'll iterate in parallel. That is going to be one iteration, second iteration, and this is parallel iteration. I say sky blue, sunset red, lawn green, pillow white, flower yellow. That is parallel iteration. For that, what I do is the following, right? An iteration before iteration, what I do, I say, hey brother, for x in x, right? So I can do that. I can say for, or we can do that, or I can say for item, or we can say for L1 or item or I1 and I2. So this is going to be the range variables declared. I1 and I2 are going to take iteration. They are going to iterate through, right? They are going to iterate in items 1 and items 2. Right? So now they are iterating through items 1 and items 2. I can say print I1 and I2. So you can print it and see what are you getting. Too many values to unpack. Now how many values will you unpack? It's not possible. Now I want parallel. I'll say, hey, wait a second. Since you are taking both the values, this item 1 will go here, item 2 will go here, and then you are iterating them through. You mind if you do something like this? In, you will say zip of items 1 and items 2, right? Now you can see. Now parallel: blue sky, red, sunset, green, lawn, white, pillow, yellow, flower. So this is how zip is going to work. It is going to join or iterate over multiple iterables in parallel, right? So if I delete this and show you the result without zip, too many values to unpack. Now you'll say, I want to unpack them and zip them. And you can say that they have been joined in parallel, right? So this is zip. And now your another question was about map. Is that so? And did we ask about map or what? Yeah, I also showed you this using zip. I also showed you this using zip as well. So let me show you. Let me take a look at time. It's going to be a longer video, so don't worry today. All right, so I'll go back to my E column. So I will go to E column and I'll go to my files. And I have two files here, sal, which is this salary, and I am having this file, right? So now these are two text files, 1 and 2. Now how many do I have? Okay, good, great. I am having two text files right here. All right, EMP and Sally. Now, can I join them using zip? Yes, I can join them using zip. Now, how? I'll again show you another example for zip. So, I will use with. With I'm using not so that the file is automatically closed. I already explained to you that it will close down the file automatically. right, e column double slash my files, and the name is, first file is going to be the employee emp.txt. So I'm opening emp.txt, and I'll open both at the same time as f1, or we can say as e, which is employee, right? And I'll open another with is still used. I'll open another which is going to be e column double slash my files, right, and it is going to be sal.txt. So I'm having two files, salary.txt, which is this, and employee.txt. So I open both the files, and I will just put a colon. How do you pronounce it? Colon, right? Okay, so I put this colon, and what I do here now, I iterate through them. I don't have to do much right here. So I'll say for, let's say about line 1, because line 1 is going to come from this, and line 2 is going to come from this. So I'll say for line 1 in. So if I do now in what? In, okay, is I did not write it down here. Okay, so let me make it smaller. I will write it down here as S. Now you are opening this file with an alias E. emp.txt has been opened with an alias E, and salary.txt, which is sal.txt, has been opened with an alias I. So I'll use in E and S. I want you to loop through A and S, right? So that's absolutely fine. But what do you want? I want you to print, right? I want you to print line 1 plus line 2. So will I be able to do this? No, you're not able to do that. So you're getting error, no such file or directories. I have lost it. E column slash my files emp.txt e column slash, where is colon? Right, so I can see too many values to unpack. You cannot unpack them, right? So what you have to do, zip them. Zip, I can see. See the magic. Fahim has 24,000 salary, Naveed has 15,000, Jahangir has 32,000, Amir has. Now you can see they have been zipped together. Fahim has 24,000, Naveed in parallel, the same thing is happening. Alright, as simple as anything. You don't need to worry about any different thing right here. Better performance, yeah, we use this with for better performance because I don't have to close the file. Had it been only open, I had to open it twice, and that too I'll have to write down then file.close, right? So that is all for your zip for the time being. Yeah, that's it, right? And let me go ahead with map now. How do you define map, right? I said map applies to a function, right? Applies to a function to every element of input, iterables, right, collections, right? And we can say number 1, map requires fewer statements and variables. So it requires fewer statements and variables, right? 2, declarative. It is declarative. And with using map, we tell the program the result we want, right? Not how to compute it, right? And it gives us results in iterables. Whenever I say iterables, it means taking hops like this. If you have a list moving from one to another and getting all the data is what I call that iterable. So let me show you a demo of that map, and then we will go through theoretical after seeing the practical, right? So that's going to be demo. So let's say I am going to define a function known as sum, and it returns, right, it returns a plus b. How simple is that? Now I don't have to pass, I have iterables to pass. I don't have to pass values here. Yeah, it is good if I say print, right, sum, and I will say 10 plus 20, so that's absolutely fine. It's no, you already know this, right? So it's, I don't have to show you this. I don't know why are we getting this error. Return, define sum, return a plus b, print sum 10 20, define sum, I don't know, okay, parenthesis of the function, I often forget it. Right now you are getting 2 arguments, so you have to pass 2 arguments right here. So I'll say a comma b. So this is function, it takes 2 arguments a comma b, and I return a plus b. So I'll get 30. So now I'm getting answer as 30. So now what if I don't have to do this? You already know this. What if I have a list of items, for example 8, 9, 10, and I have another list L2. Tomorrow you may face these problems in real world when you start developing real world applications, right? So I have 5, 6, 7. So I have 2 lists. What if I want to apply list comprehension and pass the same, right? I can say L is equivalent to, right? So now let's apply list comprehension. I'll say X for X in, right? Can I do this? L1 and L2. Now I can say print L, right? Okay, now you are getting 2 values, 8, 9, 10. You are getting 8, 9, 10. Then you are getting 5, 6, 7. You are getting 5. But I don't want this. I want to include this sum function right here. I want the sum of these two in parallel. 8 plus 5, 9 plus 6. I want to map, like in parallel, I want to map them, right? Just like I mapped string using zip. Here I want to map, but I want to include a function here. Zip will not call a function, but map calls a function. Now zip is going to only give you results joined in parallel, but map is going to call a function right here. So now if I say, hey, wait a second, go and call a function sum, right? Now it is going to throw an error, because what is that? What is happening? Nothing. You can say sum, it's going to show 8, 9, 10, 5, 6, 7, even if you are called sum. But I'll say, hey, this is not what I want. I want it to pass through map. I said map sum, which is this, and 2 parameters a and b. That's what I said. Map requires few statements and variables, right? Applies to a function. Yes, it's a function to every element of input iterables collection. That means every input item will go to the function and give you the sum. Now you can see 13, 15, and 17. Now see the result here. 5 plus 8, 13, right? 9 plus 6, 15, 10 plus 7, 17. Now you can see exactly what the result is. 13, right? 13, and now 15, and now 17. Right? Now what is this map doing? Map is sending these iterables to the function, and one by one in parallel adding them up, right? Now if you don't want to add them up, you can minus them, you can subtract, so there's no problem. 3, 3, 3. You're getting 3, 3, 3, 8 minus 5, 6, 7, 8, 3, 9 minus 6, 3, 10 minus 7. Oh, it's a common. How much, or we can say how lucky we are getting 3, 3, 3. It's a coincidence, complete coincidence. I had no intention that we'll get 3, 3, 3. But yeah, I can say, that's why I said we tell the program the result we want. Now the computer. Now how to compute it? Now you can see, we said I want you to map these two with this function and get the result of the same. And now can we do the same using Lambda expressions? Yeah, we can do the same using Lambda expressions right here. And for that we don't have to define the function right here. So now if I do the same using Lambda expressions, for that I may not be able to, or I'm not required to define the function right here, right? Why would I define function? Because Lambda expression is anonymous function. I can say now the same. I'll use the same here, L1 and L2, and then I'll say L is equivalent to X for X in map, right? And now you can say that I want a lambda expression, right? So I don't want to have just a moment. Yeah, I can say for, let me apply for, so let me say first like this. So let me apply lambda expressions. Yeah, so let me say for R in, now I will call map, and I'll say MBDA lambda. So this is going to take one, let's say about it's going to take only one parameter, let's say about X, and then it's going to do X plus 1, right? And it is going to, right, take all the items. So I'll say it's going to take L2. Now let's say print, I'll say print, how do you print R, right? I can say print R for R in map. You're already doing for R in map, which is result, right? So now you can get every element will be added with one expected and indented block. So I don't expect what indented block, yeah, inside for loop. Okay, now you can say 6, 7, 8. Now what are you supplying? Let's say about we have supplied L2. I have supplied L2, which is 5, 6, and 7. And here you can, instead of this, supply L2 as well. But yeah, you can do it using lambda functions as well. What happens? You supply L2 and it gets added with 1, and then you iterate it through. You can say 5 plus 1, 6, 6 plus 1, 7, 7 plus 1, 8. So this is what you can do with lambda expressions as well. So this is your map, and this is now the final thing that we are going to close down today's lecture is that filter. So we'll be using filter filter. So this filter offers, I write it down, offers an elegant right way of to filter out all the elements of a sequence, right? As I said, for which, right, the function returns true, right? So now offers an elegant way to filter out all the elements of sequence for which the function returns true. Now you can see that it's basically harder to get, but it's very easier to understand with practicals. It returns an iterable. So I'll just say some features. It returns an iterable, right, as I said, right, applies this expression to input iterables, all right, selects items that return true with expression, right? And what is the syntax of filter going to be? So syntax is going to be this function and sequence. Now this is going to be the syntax, right, of filter. Filter takes the function name and the sequence. Now it's easy. Maybe the points may have confused you, but the statement may confuse, but the practicals will make the statement more brighter, right? So for example, we have this function. So I'll say define even, or we can say is even. So this is the function that we use to check whether my values are even or not. So I'll apply one by one values to the function, and this is the function that is going to return me whether the value supplied is even number or it is an odd number. So now I'll say I'll go inside the function. I will say if, hey, wait a second, if a modulus 2 is equivalent to 0, what you got to do, if it is equivalent to 0, that you return true back to function. If it is not, then you return false back to function, right? So let me run it. Yeah, absolutely no problem. So now let me call this function. For example, if I am having list 1 as L1, right, and what I do here is I pass some values, right? Yeah, I have some values that I need to pass, so I'll pass. And let's say about L1 has 1, 2, something, 1, 2, 3, and I'm going to take 8, 6, 11, 7. So these are the values. Now you'll have to see even, right? Maybe 2 is even, and let's see what we get. Okay, all right. And let's say L2. Let me apply list comprehension here. So I will say I'll apply list x for x, right? X for x in. Now I will call this function is even, and I will supply this L1, right? So is even takes one parameter, and I will apply that parameter as L1, right? Okay. So now will this work? So now this is not going to work for me. Unsupported operand, right? You can clearly see it is unsupported operand, right? Why is it unsupported operand? Because you are supplying list, and why are you dividing list? So for that I will say, hey, wait a second, I want map. Now if I supply map, what is map going to return me? Now let me, okay, I am going to go map is taking 2 parameters right here. So now you can see, okay, true and false has to be capital, sorry. True is capital, true, and false is capital. Now if I do map, all right, and now if I say print L2, now you can see map is going to return us this, right? So now map is going to map the is even function and L1, which has 1, 2. So now return true and return false. So map is going to take true and false both. Now you can see false. Now is 1 divided by 2 0? No. Is 2 divided by 2 0, or 2 modulus 2 0? Yes, the remainder is 0. Yes. So you'll get true here. Now let me have it here. Let me copy the result here. Right, so let me copy. So false is 1, true is 2, false 3, true 8. 8 is completely true. You can see that right here. 8 is true, right? And 6 is also true. 2 into 3, 6. Yeah, true. False. 11 is false, and this is false. Now if map is doing what, why do we need filter? Now in case I don't require both the values, I require only the true values, right? So I can say here, hey, return this. That may happen, but I'm getting true, but I'm also getting this comma right here, right? I'll say else don't return anything, right? So in that way I'm getting none, but I need only true. Why don't you get it? I need only true. So for that I will use filter, right? As I have already said, offers an elegant way to filter out all the elements of sequence for which the function returns true. So for which the function returns only true. Why? Because map is showing true and false both, right? It returns an iterable, yes. Selects the item, right? Return true with an expression that it is that, right? Filter function. Now you are using filter function. That's the syntax. Call filter, pass the function. Function name is even, and sequence is this right here. Now run it. You're only getting items which are true, and that you're not getting true false. You're actually getting the items themselves which are true. Now 2 is divisible, 8 is divisible, 6 is divisible. Now what was map giving me? Map was not giving me those items. Now map was giving me everything. Yeah, map was mapping it down, and then we get true or false. But yeah, this filter is actually doing a magic for me. it's giving me I triples, right? You can see applies the expression to input I triples, and it returns I triples. It itself returns I triples, unlike map, right, which will tell the program that result we want, not how to compute it, and it's also results in I triple. But here, once we filter, the results in I triple are only results that we want, not true and false like this. Now here we are getting true and false, but here we are seeing filter. Hey, go to is even. Is 2 getting true? No. 1 is not getting, skip it. Is 2 getting true? Yes, show 2. Is 3 getting not? Is 8 getting yes? Show it. Is 6 getting yeah? Show it. Is 11 getting no? Is 7 getting no? Show. So all those who are returned true are actual items that are going to be shown by this filter function. So this is filter for you. So now what we have learned so far is quite a while and quite a bit, right? We completed filters, we completed map, we have completed zip, and we have completed lambda expressions to some good extent, right? And as promised, lambda expressions will not be completed without we learning kw args and args tomorrow. But I want you to practice this. I shall keep this file readily available for download. Kindly download this file down in the description section, and let me know in the description section if I can help you, if you have understood, if you have not understood, in case you have misunderstood, right? And keep the spider ready. Practice hard for lambda expressions, practice hard for zip, map, and a filter as well. So this is the longest video I've ever recorded for you guys, I suppose. Yeah, it's already 1 hour 6 minutes. So I wish you all the best. I'll see you tomorrow. Do practice very hard. I'll give you a good amount of time to practice for it. Right, and this is very important. The more important thing, the most important 3 things: map, filter, and zip, that we are going to use in data analytics along with lambda expressions. Until then, let me know down in the comment section if you want any change and everything else. Bye bye. Take care. See you tomorrow. Take care of yourself. Bye bye.